When we work on designing heating and cooling systems, one factor we need to consider is how does the heat transfer from a hotter place to a colder place. And we're thinking here about a kind of heat called sensible heat. There's sensible heat and latent heat. We're talking about the kind of heat we can feel and a temperature difference we could measure with a thermometer. There are three mechanisms for transferring heat: conduction, convection, and radiation. Conduction is heat getting transferred by materials that are in contact. So if this handle on this pan is hot and you put your hand on that handle, your hand will feel hot. That's conduction. If you take this pan and you set it straight on an electric burner, which I don't have a picture of here, so that it's in contact with the burner, that's conduction. Convection is different. Convection is heat energy that moves through the motion of a fluid, and it could be a fluid that is a gas, could be air, like rising from this campfire, and it could be a liquid, like hot water coming from the boiler in your system. Convection depends on the idea that heat rises, and to be precise, fluids that are hot have their molecules jumping around more, so the molecules are farther apart, so the density is less, so the material is more buoyant. If it's cold, the molecules are jumping around less, so the material, the fluid, is dense and it falls. So we always depend on that idea that hot air or hot liquid rises. If we need to direct heat downward, we're going to need to use a fan or a pump. Now, radiation is different from conduction or convection. Radiation has heat energy moving through space through electromagnetic waves emitted by a body. And that body could be this heater, it could be this person, it could be the sun. Every object emits electromagnetic radiation. And what kind of radiation it is depends on the wavelength. How long are those electromagnetic waves? So if you look at this picture here, this diagram represents that at a certain wavelength, those waves produce light, which we are wired to see with our eyes. When the wavelengths get shorter than visible light, we get into ultraviolet and then even shorter X-ray and gamma ray. As the wavelengths get longer, we get into infrared radiation, and even longer than that, microwaves. Microwaves that come out of your microwave oven are actually there's quite a long wavelength. These are quite far apart. I forget what the measurement is, but it's long. And then radio waves are even longer. So in this wavelength zone here are infrared rays. Every object emits radiation, and if you are a human body or a rock on the ground or a table in the room, you are emitting terrestrial radiation. You are in that wavelength spectrum that is infrared. An object can radiate in all directions, and let's say you're in a room with, I don't know, a wood stove, which has pollution problems, but it does emit radiation. The hot stove loses heat by radiating because the other objects in the room have lower energy, it has higher energy, and so that those infrared waves go from the hot place to the cold place. What is interesting about this for an HVAC technician is that you can have a device that emits heat through radiation, like a wood stove or an electric space heater, and you can feel comfortable even though the air in that room might be cold. The air does not have to be the same temperature as the heater thing. So a device that emits radiation is actually, what would you say, economical, efficient.